Alright class, we are here on our last video of chapter 10. It's actually a section that we grabbed from another section of the book, so it's called section 12.3, but really the big idea, areas of sectors and segments. Alright, so for both of these we need to understand this idea of central angle. A central angle is kind of what it sounds like. It's an angle whose vertex is the center of a circle. Okay, so right here is a perfect example of a central angle. I know it because the vertex is directly in the center. Okay? Now, an arc is an unbroken section of a circle consisting of 2 points on the circle called the endpoints, and all the points on the circle between them. Alright? So the idea is, sure, we have points R and S. The arc itself is that entire piece of the circle, or the section of the circle that's between those two endpoints. Okay? Cool. Now, why do we need that? We need that, or those definitions, excuse me, because we're going to be finding the area of these things called sectors. Alright? Now, a sector is a region bounded by 2 radii of the circle as well as the intercepted arc. Alright, so this is a great picture right here. I would call this sector ACB. Okay, sector ACB. But what I need to understand is, well, what is a sector? Oh my gosh, it's just like it's a part of a full circle. So question for you. If I know, like let's think about this. If I know I have a circle with a radius of r, and I wanted to get the area, I would use pi r squared. But what we are doing is we're just finding a sector or a section of the original circle, okay? So what we do is we start by using our original formula, pi r squared. That's what we work off of. And what we need to do is we need to take the fraction m over 360. Okay? Now the reason we use this m, which is the central angle or the measure of the angle, is because I know all the way around the circle, right? If I start at B and go all the way around, that's 360 degrees. Well, I just want the fraction of the part that's shaded in, and so we use the angle, the central angle, divided by 360 times our original area formula. Okay? So this is the new part, right? Whoop, that was bad. New. Okay? Let's put it to work. So, when we look at something like number 1 on the top of the next page, I notice that my central angle is 80 degrees. Alright, 80 degrees. So when I go and I plug into my formula, 360 times pi r squared, well, m is 80. And my radius is the 3 that I see. Okay? So we would go to the calculator here, and what I'm going to do, because I don't have one of the other calculators, I'm going to do everything but without the pi. So I'm going to do 80 over 360, and then I'm going to multiply that by 3 squared. Again, what did I do? I just did everything without the pi. I know I'm going to put it on later, so this is 2 pi. Alright, so 2 pi, and remember this is area, so units squared. Okay? Okay. Let's try one more. Ooh, here's one where we have to be careful that we're making sure we plug in what we want. So I'm still going to use m over 360 pi r squared. I guess I didn't need those parentheses, but whatever. Please make sure that we plug things in correctly. We have to remember 72, is 72 degrees the angle of the shaded part? No, it is not. So we need to remember that half of a circle is 180 degrees, which means the angle I'm going to use is actually 180 minus the 72. What I want is 108 degrees, because that is 180 minus 72. 180 minus 72 is 108. Okay? So now I have the measure of the central angle. I also know, so let's see here, 108 over 360 pi. What am I going to plug in for r? Hopefully at this point you guys are feeling decent at this. We're going to plug in 5. And why is that? Well, because my diameter is 10. So now go to the calculator, 108 over 360 parenthesis 5 squared. I get 15 halves. So 15 halves, and then I put the pi back in. This one didn't have units, so I will use units squared, and we are good to go. Okay? I think I'm going to save 3 to do in class, unless if you guys want to try it, feel free. But I'm running out of time before next class, so I want to make sure I introduce segment to you. A segment is right here. Okay, a segment of a circle is a region bound by an arc and its chord. And we have not necessarily talked about the word chord. A chord is basically like RQ. A chord from one point on circle to another. Alright, so notice we can either draw a straight line from R to Q, that's called the chord, or we can draw the arc between R and Q, and what we care about is that area in between. Okay? Oh wait, yeah, so that's good. Okay, so here we go. Here we have our segment. And what we need to do really, guys, is we need to take the sector and take away the triangle. All right, and that's what we're going to do every time. All right. So the segment is equal to a sector minus the triangle. Let's take a look. So, in my original picture, hopefully we agree this is a segment. I can tell because it's the area shaded between the chord and the arc, so that's good. We also know the central angle, is 90 degrees. That's going to be helpful for a couple of reasons. So let's start by getting the area of the sector. All right, if we have a sector, we know that we use m over 360 pi r squared. So m is 90. 90 over 360. And I know that the radius of this circle, is 4. So I'm going to plug in 4 squared. So let's see, when I go to the calculator, I think it's 4 pi, but let's just make sure. 90 over 360, 4 squared. 4, so 4 pi. So now I know that the area of the sector is 4 pi, but please remember, we are not done. We now need to find the area of the triangle. I need you guys to understand, always use 1/2 AB sine C. Okay, 1/2 AB sine C is going to help us get this every single time. So 1/2 AB sine C. Now, why is that going to work? Well, because you're always going to have that central angle. And guess what? You're always going to know those two sides. The two sides are just the two radii that we talked about earlier when defining a sector, right? We talked about 2 radii. So those are the sides. So A and B are both going to be radii. So 4 and 4. Like that. And then remember, all we know is that the angle that we use here has to be the included angle, or the angle between those two sides. In this case, it is 90. All right? So we would go, I'd plug all this in, 1/2 times, 1/2 times 4 times 4 times sine of 90. Wait a minute, I think I'm in the wrong, sorry, degree mode. We'll try that again. Boom, 8, great. So now I know that my area is 8 for the triangle. Last thing you must remember, to get the segment, right, we do what? Sector minus triangle every time. And why is that? Well, the triangle's like the white space, right? We need to remove that from the original sector. So my answer is 4 pi minus 8, and we are in meters squared, which then, again, for those of you without the nice calculators that'll do all this, should be something like 4.6. 4.6 meters squared. All right, both answers perfectly acceptable. So please make sure that you practice both of these, or kind of understand these before we get to class. Remember, a sector is just a slice or a fraction of a circle, right? So that's my hint, that I have to use the fraction out of 360 when I calculate the area. The only thing you really have to remember for segment is that it's almost like that little slice where you remove the triangle, or it's the crust of the pizza I'm almost thinking about here, right? So I have to get the area of the full sector and then remove the white space, or remove the triangle. All right, there you have it. There's our last video of chapter 10. Good luck.